All right, so we are going to be talking about proportions today, specifically how we're going to solve proportions. Proportions are a particular kind of equation, and we spent a lot of time last semester solving equations. This is a kind of equation that we haven't really seen, at least as far as this class goes, but they're pretty easy to solve. There's a couple of definitions we need to talk about before we get into solving proportions. The first is a ratio. Who can tell me what a ratio is? So a ratio is a comparison of two numbers or two quantities. And so a lot of times when we're talking about a ratio, we're talking how much out of something or what portion of something we're talking about. And that's why portions have something to do with proportions. But a ratio is just a comparison of two numbers. So a ratio is a comparison of two numbers using a fraction. So a ratio might be like 2 out of 3 students in the school like math class the best. That would be a ratio, 2 out of 3. The other definition that we're going to need to know to solve proportions is what a proportion is. Does anybody know what a proportion is? Has something to do with ratios. That's why we just defined a ratio. A proportion is just when ratios are equal to each other. So when two ratios are equal to each other, we call that a proportion. And when things are equal to each other, we use an equal sign, so we're going to end up with an equation when we're looking at proportions. The first thing we want to do here is determine if two ratios are equal to each other, two ratios are proportional. So remember, ratios are just a comparison of numbers using a fraction. So how could I tell if two ratios are proportional? What does proportional mean? You just wrote it down. When two ratios are equal. So how can I tell if two ratios are equal? Or two fractions are equal is basically the question, right? So two ratios are proportional if they're equal. That's it. It's that simple. So two ratios are proportional if they are equal to each other. And so what we're going to be doing here is when we want to know if two ratios are proportional, we just want to know if the fractions are equal to each other. So you're going to get two fractions and you're going to determine if they're equal to each other. So then what we're going to have to do is find a way to figure out if two fractions are equal to each other. So in this first example here, we want to know if 3/4 and 6/8 are proportional. Now, looking at it at first, the fractions look different, so we might say, no, they're not equal, so they're not proportional. But we have to look a little bit more closely. What could I do with one of those fractions? Gabrielle?
Divide the 6/8 by 2.
Okay, so if we reduce by 2 here, what do we end up with, Gabrielle?
3/4.
Okay, so what do you think? Are 3/4 and 6/8 proportional?
Yeah.
Why?
Equal.
Because they're equal to each other. So when we reduce one of them, it becomes the same as the other one, right? So one way to see if if ratios are equal to each other, and therefore the numbers are proportional, is to just reduce the fractions. If you reduce the fractions and they're the same, then they're proportional. Alright? Now, that's not going to really help us when we get to solving proportions later on. So let's look for another way that we could tell if they're proportional. So another way of checking to see if two ratios are equal to each other is to cross multiply. So I want you to do this also. Go ahead and write this below it. Rewrite the fractions. So we have 3/4 and 6/8. And what we're going to do is we're going to cross multiply, meaning I'm going to multiply the numerator of one of them with the denominator of the other one. What is 3 times 8? Okay, and then I'm going to do the same thing here. I'm going to do 4 times 6. And what is 4 times 6? And so what does that tell me? since the cross multiplication numbers are equal to each other, that means that these two ratios are proportional. So to answer the question, it says determine if the ratios are proportional. We'll just say yes. Be good enough. Yes, they are proportional. You don't have to write that whole thing out, but they are proportional. With this example, we could do the same thing we did first on the other one, and we could reduce both of these. We could reduce both of them by 4, and once we reduce by 4, we could see if they're the same. See if they're the same fractions. But that's a little bit more work than what we need to do, because all we have to do here is what? Jake? Aaron? Cross multiply. So cross multiply here and just type into your calculator. You've got that at your disposal here. 24 times 44 is?
488.
What is it? 4,088? 488? Okay, I'm not sure where Claire got that, but 1,056? Multiplying. 44 times 24. And then multiply the 20 times the 40. You get 800. So are these proportional? No. So we'll say not proportional.
You just say no.
That would be okay too. We can use that same idea to solve a proportion. And so what we're going to get, you don't have to write this down, but what we're going to see is equations that are going to have two ratios in them. And it might have a variable in any one of those positions, but it might look something like this. And you don't need to solve that one. But since this is an equation, what we can do is we can solve for x by getting x by itself. Now, to solve a proportion, we can use that trick that we just did. What did we just do to see if two ratios are proportional?
Cross cancel.
We didn't cross cancel, we cross multiplied. So what we can do here, since we know that these two have to be equal to each other, we can cross multiply and say that those products are equal to each other. So we would do 4 times 5, and we would do x times 6, so we would say 20 equals 6x and then solve. Alright, so you don't have to do that for this example. We're not going to do this example. We're going to do other ones. But to solve a proportion, we're going to cross multiply. And then once we cross multiply, we're still going to have to get the variable by itself. So we're going to cross multiply and then solve. And we know how to solve those equations, so I'm not going to put the steps to solve that equation. But almost always you're going to cross multiply and then divide. In this example, we want to solve for a. And so what we're trying to do here is we're trying to figure out what number we can put where a is so that these two ratios are equal to each other. So that if I take this fraction and I reduce it, I'm going to get this fraction. There's a lot of different ways we could solve this, but one way that's always going to work is just going to be cross multiplying. So let's use that here. What do I get when I cross multiply here? Atlas? Yeah. Okay, so when we multiply the 2 times the 6, we're going to get 12. And then on the other side, when we multiply the 3 times the a, what do we get? 3a. So we've got the equation 12 equals 3a. And then Atlas, what do I do to solve that equation? Yeah, we need to divide by 3 here to get rid of the 3 in front of the a, and we divide by 3 here because whatever we do on one side, got to do on the other. And so 3's cancel here. What's 12 divided by 3? And on the right side, when the 3's cancel, what's left? So we get 4 equals a. If you wanted to know what number would go up here to make this fraction the same as this fraction, we could multiply this by 2 to get that, right? So we could take 3 times 2 to get 6. So if I take 2 times 2 on top, I multiply by the same thing, I get 4, right? So that would be another way to do it, just kind of thinking about what would it take to make those two fractions equal to each other. And that way would work sometimes, but it's not going to work on all proportions, because some proportions we're going to get some decimal answers. So let's go through and let's just do a few more examples by cross multiplying. This one we have 2 over 3 equals 6 over b. This one's really similar to the last one, except now the variable's in the denominator instead of the numerator. And so what are we going to do to solve this? Alicia, what do we do? Okay. Okay, so 6 times 3 is 18. We get that on one side equals 2 times b, which is just 2b. And then what do we do to get the b by itself, Alicia?
Divide 2.
Okay, we'll divide by 2 on both sides. Not just by the 18, but on both sides, right?
Yeah.
18 divided by 2 is?
9.
And when the 2's cancel over here, what's left?
3.
So we get b equals 9 here. Alright, next example. We have 20 over 24 equals c over 12. Alright, so what are we going to do to solve this? Cyan, go. 20 times 12, which is? Okay, so we get 240 on one side equals 24c. And then how do we get c by itself? Divide by 24 on both sides. What is 240 divided by 24? And what is 24c divided by 24? So we get c equals 10. Okay, everybody good with that one? Now, Atlas pointed out there's a good way to do this one, another way to do this one. If you notice here that 12 is half of 24, so you would do 24 divided by 2 to get 12, then what could I do up here? Divide by 2. If you do the exact same thing on top and divide by 2, what are you going to get? So you get c equals 10, right? So you can do that, and just by doing that, you can figure out that c equals 10. If you notice something like that, you can do it that way. Just be sure that you write your answer in an appropriate way. Make sure that in this case we're solving for c, you need to write c equals and then whatever the value of c is. Don't just fill in the proportion. Don't just put a 10 where the c is. That would be a valid proportion, but it doesn't really tell you what the answer is. All right. I will tell you that on this one you will not be able to solve it that way. So you're going to have to cross multiply on this one. There's no shortcuts here. What do we do first, Aaron, to set this up? Okay, so 5 times 7 is? And d times 6 is? 6d. Be sure that you put the number in front and the variable second. That's just the way we do that. So we would say 6d, not d6. And then, Aaron, what do I do to solve for d? Okay, we'll divide by 6. And when we do that, we get the d's cancel on the right side. Or, I'm sorry, the 6's cancel on the right side, and we get d by itself. How about the left side? Aaron? 6 does not go into 35 evenly. So it ends up being, what, about 5.83 something?
Yep.
So since it doesn't go into it evenly, you'd have to write your answer however you're asked to write your answer. Now, I didn't tell you to write your answer as a fraction or to write your answer as a decimal or to round your answer. So on this one, you would have to be told how to write your answer. If I asked you to leave it as a fraction, all you would have to do is check to see if you could reduce this. Can you reduce it? No. So since you can't reduce it, you could write the answer as 35 over 6, and that would be your fraction answer. If I ask you to write it as a decimal, then you would have to know something else. You would have to know either how many places to round it to, or What else could you do?
Or you can just
Write it.
Write it as a,
Decimal.
what kind of decimal?
Repeat.
A repeating decimal, right? Because when we do this, we would get 5.83 repeating. So that would be another way to do it if I asked you to write it as a repeating decimal. Or if I ask you to round, say, to the nearest hundredth. Then what would you do?
You just gonna round to the nearest hundred.
Yeah, so the hundredths place would be this 3 right here. What number would be next to it?
Three.
Another 3. So it would stay the same, right? So to the nearest hundredth, it would be just 5.83. We might do something like that if we're talking about money, right? So if we're talking about money, we would round to dollars and cents. So it wouldn't make sense to have 5.83 repeating if we're talking about money. There's no such thing as a third of a cent. So any one of those would be an okay answer, just depending on how I ask you to write your answer. And so when you're taking a quiz or when you're taking a test or when you're doing a worksheet, it will say in the directions how to write your answer, whether it's as a fraction or as a decimal or as a rounded decimal. Any questions about any of those?